Now that we have an understanding of the restriction and what an inverse trig function is looking like and behaving like, let's find the exact values. So we're going to start with this example right here where I want to know what is the inverse sine of 0. And when I look at inverse functions like this, the question you want to ask yourself is, well, what angle did we plug into the function to get x? So in other words, what angle, when I find the inverse sine of it, gives me 0? So I'm going to start by drawing a picture first. What angle, when I find the sine of it, gives me 0? And I know that when I know that this point over here at 1, 0, and this point over here at pi, which is negative 1, 0, which is negative 1, 0, at 0 and pi, when I take the sine of 0, I get 0. When I take the sine of pi, I get 0. I also know, because we have restricted our inverse functions, that the inverse sine function only lives over here in the first and fourth quadrant. So the answer to this is, when I take the inverse sine of 0, that is 0. So that answer is 0. Okay, let's look at another one. Let's look at the inverse cosine of the square root of 3 over 2. So you ask yourself, for what angle, when I take the cosine of it, do I get the square root of 3 over 2? So looking at my my graph right here, I know that cosine, when I take the inverse cosine, or when I take the cosine of an angle, I get positive square root of 3 over 2, meaning that I have to be somewhere over here in the first quadrant, because cosine is positive here. I could be down in the fourth, but I'm thinking I'm here first of all. And the square root of 3 over 2 is when I take the cosine of pi over 6, right? So the cosine of pi over 6 gives me the square root of 3 over 2. Now the next thing to remember, again, since we're thinking inverse functions, cosine lives only up here in the first and second quadrant. So even though there is an equivalent answer that gives me a positive square root of 3 over 2 in the fourth quadrant, that answer isn't valid because I'm only allowed answers that lie in the first and the second quadrant. So the answer would be pi over 6. Okay, are you getting the hang of this? Let's try another one. This time we want to look at the arc sine of negative 1/2. So again, you're going to ask yourself, and sometimes I write it like this. So for what angle, when I take the sine of some angle, I get negative 1/2. When I take the sine of some angle, I get negative 1/2. So that has to occur. For sine to be negative, I have to be down here in either of these two quadrants. And because I know my inverse sine function can only live in the first and fourth quadrant, I'm looking for an angle that's down here in the fourth quadrant. So in order to get the sine of negative 1/2, I would normally be looking at, let's see, I would normally be looking at pi over 6. Up here, that's pi over 6 for the reference angle. But down here in quadrant 4, now you might be thinking that this would give me 11 pi over 6. But notice what happened when I chose 11 pi over 6. I come out of the zone, don't I? I come out of the blue zone and enter back in. So I cannot use 11 pi over 6. Instead, I have to move negative, and I have to choose negative pi over 6. So if I just go negative, I stay within this blue zone, and my solution is then valid. So the answer to this would be negative pi over 6. Okay, let's try one more together. Let's look at cosecant, because this one's kind of hard to think about at first, since it's not one of the sine, cosine, and tangent functions. So we're looking at cosecant of negative, the inverse cosecant of the square root of 2. Okay, so cosecant, first of all, inverse cosecant is going to live in quadrants 1 and 4, similar to sine. So it has to live here in quadrants 1 and 4. I know also, so I'm asking myself, let's back up. I'm asking myself, so for what angle, when I take the cosecant of it, I get the square root of 2. I can think, since I know cosecant and sine are reciprocals of each other, maybe I want to look at this as the sine of what angle is 1 over the square root of 2, because these are reciprocals of each other. And if I think in terms of that, I know that this has to be, to get a positive sign, I have to be looking at an angle here. I have to be looking at pi over 4, because that's going to return for me a positive sign, or when I take the cosecant of pi over 4, I get a positive cosecant, and that's my solution. That's my answer. So I'm staying here in quadrant 1, and the answer to the inverse cosecant of the square root of 2, or for what angle when I take the inverse cosecant, no, for what angle when I take the cosecant of it do I get the square root of 2? And that angle is pi over 4. So pause the video. I want you to try these two on your own, okay, just real fast, and then we'll come back together and see what we get. Okay, so hopefully you tried these two on your own, and let's talk about our solutions. When I take the inverse sine of -2, I tried to trick you on this one. -2 is not in the domain for inverse sine. Remember, my possible input values for sine are only numbers between negative and positive 1. So since this is outside of my domain, there's no solution to it. Just watch out for that. The next one I asked you to do is the inverse cotangent of negative square root of 3 over 3. So I went about this a couple of different ways. First of all, I drew my picture and determined what area the inverse cotangent lived in, or which was quadrants 1 and 2. Now, I asked myself, so for what angle when I take the cotangent of it, or the cotangent of what angle equals the negative square root of 3 over 3? And I went ahead and rewrote that as -1 over the square root of 3. So I kind of reversed this. That's what it would look like normally. I did that because I recognized that cotangent and tangent are reciprocals of each other, and I can take the reciprocal of this to where it looks like just negative square root of 3. So what I'm really asking myself at this point is, the tangent of what angle is equal to negative square root of 3? And that's going to lie in quadrant 2, because that gives me a negative answer, and that is here at 2 pi over 3. So the solution to that is 2 pi over 3. Hopefully you see from these series of examples that the best way to approach this is to make sure that you're drawing a picture of what where your solution lies, and then you make sure that you're moving in the negative angle if that's appropriate, or perhaps even using our reciprocal angles if that's appropriate.